In the previous lecture, we created a rig to evaluate if a point in space was inside or outside of a mesh. Since this is something we may wish to do again and again, it makes sense to package the functionality into something reusable, and in Modo that usually means an assembly. Let's start where we left off last time. In fact, the sharp-eyed amongst you will notice that I've done a little tidying up, but other than that, the layout is the same as before. So first things first, let's create ourselves a fresh assembly and give it a sensible name, and the assembly appears in the current workspace. If we look inside it, we'll see that it's ready for us to set up with inputs and outputs. We might as well make a start on that now. Let's add an input to this assembly. The input will be the position. Now we can either choose to represent the position as a vector, x, y, z, or as a matrix. And for a lot of circumstances, a matrix is more convenient, but it's up to you, I guess, as to what you have as your input. So let's use a matrix in this case. OK, so now have an input to our assembly. We also need an output, and the output in this case will be a Boolean to tell us whether or not we're inside or outside of the mesh. OK, let's go back to the workspace, and you can see that our assembly now has the position input and the Boolean result output, different colors to tell us which is which. We now need to move our rig into this assembly, and that's as easy as selecting these and choosing to move them. So let's select all of those. Sure, there are better ways of doing that. Right click, move nodes to assembly, and they're in there. Let's have a look inside, and we can see that all those nodes have now been moved into our new assembly. It's also mucked up some of the layout, but that doesn't matter because we're going to get rid of a lot of these things. So the first thing I'm going to do is replace all of the world positions coming from our probe with the position coming from the input to the assembly. So what have we got connected? We've got this one here, so we can connect that. There's some more. If you hover over these connections, you can see more clearly where they're going. So we've got one that's going all the way over there, and one that's connecting up to the direction constraint. So connect up to the direction constraint, and finally another input to our intersection over here. Which input is it? It's the input 2. So position goes to input 2. Right. Having done that, we can now start tidying things up a bit. Now, this locator here isn't doing anything for us. It's just forwarding the transformation from one node to another. We used it because it was showing us what was going on. We don't need it anymore. So rather than have that there, we can just short circuit that connection and get rid of that locator. Similarly, we have the direction constraint outputting a world rotation. The rotation comes from the direction constraint and goes straight into the intersection. So again, we can just short circuit that connection, and we don't need that anymore. Our probe is now looking rather sad. We might as well just disconnect it. This locator, the ray hit locator, was only really there for our information, so we can delete that. And finally, I think we've replaced all of the uses of the probe. We can delete that too, and it's gone. So now our rig is a lot more manageable. Bear with me whilst I move stuff around a bit and make it a bit easier to follow. And really, if we can fit it all into one screen, that would be nice. I think we can just about manage that. And now finally all we need to do is connect up the result to our result output. We can get rid of that whilst we're at it, since we're not using it. Similarly with that channel. And there we are. So this is our assembly version of the rig that we had before. If we go back to our workspace, we should be able to test its behavior. So we'll need something to feed into the position. Having deleted all those locators, I'm now going to create a new one. Bring the locator in and add its world position channel. Connect that up to the volume, and our locator currently is inside that cube. The result should be true, and it's true. Marvelous. If we move the locator outside of the cube, then the result should be false, and it is. So it seems to be working. Now, this assembly isn't very useful because it's got this cube burnt into it. So the next stage is to make this assembly be parameterized over the geometry. So we want to be able to feed the geometry in from the outside rather than have it burnt into the assembly. So in preparation for that, let's go back inside here, select our mesh and remove all the geometry from it. So we've got a nice fresh empty mesh. So how are we going to import geometry from outside of the assembly? This is where procedural geometry comes to our rescue. There's an operation called merge meshes which imports geometry from other meshes. So let's select the mesh that's internal to our assembly, go into the Mesh tab and add the Merge Meshes operation. Can bring that into the assembly, and we want to expose the sources input to the merge meshes. If we right click on that, we can then select Expose Single Input Relationship, and the sources have now been exposed. Let's go back to the workspace and we can see that the new input is available for us. I guess we ought to test it. So we'll need to create a new piece of geometry. Get the model and let's create a cube. Drag the cube into the workspace and connect it to the source input. We're outside the cube at the moment, so the result should be false. So far so good. We select the locator and move it inside the cube. Our output should now be true, and it is. Excellent. Okay, and we're not restricted just having one piece of geometry. We can add another piece of geometry. Let's be different and add a sphere this time. Drag it in, add it to the sources, and grab our locator. So we're between the sphere and the cube. We should have false. If we move it inside the sphere, we should have true. Excellent. The plan is coming to fruition. Right, there's something a little bit awry with this because this mesh is importing the geometry from the input meshes, and we can see both versions. Okay, so visually we can't really see much difference, but we really ought to hide this mesh because otherwise we've got two versions of the same geometry in our display. So let's go to the Properties, Display, and if we check No in the Visibility option, that will hide the meshes that have been created inside of our assembly. We don't need to see those. Okay, and I think that's about it. There's one last thing we could, I guess, add to the assembly, and that is an option to toggle the sense of the output so that we can have true for outside rather than true for inside. And that's very straightforward. So let's add a new input to our assembly. We'll call it toggle. It's Boolean. OK. And what we want to do is essentially change the sense of this result output. And the easiest way I can think of doing that is to use the not equal operator. So how does that work? Well, I think it's easiest just to look at this little table, which will show you how the various values work out. So when the toggle is false, the output is the same as the input. And when the toggle is true, the output is the opposite of the input. And finally, once we've created our assembly, it's a good idea to save it. And you can do that either by selecting it, right-clicking and Save Assembly Preset, or in the File menu, Save Assembly Preset from there. I'm going to finish off this video by showing you a couple of examples of the inside volume assembly in action. In this model, I have a procedurally generated funky torus shape and a plane, and attached to this plane is a constant texture. But this constant texture is far from constant, because we've used the texture coordinates from its texture locator, turned those into a matrix, and then fed those into our inside volume assembly, so that those values that are inside of the funky torus will be a different colour to those that are outside of the funky torus. And we achieve that by feeding the result of the inside volume assembly into a colour blend, which is going to blend between two different colours, a red or a green. In order to see this, we're going to have to bring up the preview renderer, and we'll also need to hide the funky torus. And there you can see that those regions inside the volume are one colour and the regions outside the volume are another colour. If I move the object, then we would expect to get a slightly different result. And there we do. In this example, we're using the inside volume assembly to control where particles are created. So we have this shape, the funky capsule, and what we would like is for particles to be created on this plane within this shape. So by using the inside volume assembly, we can look to see whether or not a particle position from this particle operator is inside the volume or not, and if the result gives us back that it is inside, we will keep it. If it's not inside, we will kill it. And the particle operator is set to act on new particles only. And if we run the simulation, it doesn't work. I'm not sure why this is, but I've found a useful workaround that makes it work. If we go into our inside volume assembly, I've added some extra nodes, and what I'm doing is I'm interrogating the mesh that's been created to find some information about it. For example, in this case, the number of points. And if I use that number of points, combine it using a logical AND with the result that we ordinarily would have calculated, and then that result just carries on down the chain as before. If we hide the funky capsule, then things will work as expected, and the particles are now created inside of the capsule. So just to be clear, this isn't actually changing the behavior of the assembly in any way, except making it work. This number of points is always going to be greater than 0 if the mesh has any geometry in it at all, so this AND isn't changing the result because anything other than 0 is considered to be true. So true and true will be true, true and false will be false, so the value coming in here will just be echoed to the result. So as I say, I'm not sure why we need to do that. It may just be some quirk of the way that things are evaluated, but I've found that it's a useful workaround. And I should point out that these shapes, the funky capsule and the funky torus, they're procedural geometry, and it's also possible to animate that procedural geometry and everything still works. And that's it for this episode. As always, thanks for watching. I hope it was useful, and I'll catch you next time.